of the basics of our statistics. So we're going to start today, and we're going to talk about sampling, and we're going to talk about some of the key vocabulary, sampling methods, things like that. Real basic. This goes into a lot more depth that we don't have time to cover, but know that this is just kind of the surface of that. So data is what we're looking at. It's the numerical representation used as a basis for reasoning, discussion, or calculations. Numbers that have meaning and represent different things. Statistics is how we get that data and what we do with that data. It's how we collect it, how we gather it, how we organize it, how we analyze it, how we interpret it. And sometimes we will draw conclusions based on that data. We have two types of statistics, descriptive and inferential. Descriptive is kind of that first part with it's just getting the information. There's no way, well, very little way in kind of skewing that. It's just purely collect it, organize it, summarize it. Inferential statistics, a lot of times, is how we get into a little bit of trouble. It's what we do with that information, how we interpret that information. Okay? I'm going to talk about this again later, but there was the former finance minister of Britain, I think it was, long time ago, not the current one, who said famously, there are liars, there are damn liars, and then there's statistics. And basically what that refers to is that depending on how you interpret the data you get, it can be used for great good or for great evil. So in general, when you're looking at statistics, it's very important to be aware of not only the information that's being presented, but how it's being presented and who is presenting it. Can make a really big difference on the accuracy of the interpretation of that data. Okay? So, in general, two of the first basic things we look at with statistics is our population and our sample. The population is everything that we are trying to gather information about. It is the entire group of people or objects whose properties are being described by those statistics. Okay? When we look at a set of information, and we have a table here showing the most popular TV shows during the 20th century, all right, the ones that had the highest viewing percentage. So MASH, which was a show in the 80s, had 50 million households approximately that watched the show with a viewing percentage of 60.2%. Dallas had 41 million with 53%, and then Roots had 51%, just under that, with 36 million households watching those shows. Okay? A lot of people. So the population would describe everybody in that data set. So what do you think the population would be if I'm looking at 60% of people watch MASH? Everybody that we're trying to describe. The population. What information are we looking at in general? What are we trying to describe? Okay. Total households that do what? That have TVs. Total number of households that watch TV. That is our population. If there's a household that doesn't have a TV, then there's no point in including them in the population because there's no way they're watching MASH or any other show. So they're not going to be included in the population. We're looking at total households that have and watch a TV. Okay? That's our population. And so 60% of those households say, yeah, we watch MASH. It would be really unrealistic to go around and ask every single household that has a TV, hey, what should you watch? What should you watch? What should you watch? What should you watch? Impossible to do, especially when they have 50 million that do watch MASH. So you're looking at somewhere around 70 million households. There'll be a lot of people that ask. So In order to find this information, we use a sample, a subset or a subgroup, a smaller portion of that population, and we ask those people, what should you watch? Do you watch this show? Much easier to gather information from, say, 10,000 households versus 70 million households. And then we use the information from that subset to make a generalization about the entire population. There's no way that we could figure out that exactly 50 million people watched MASH. That's just an estimate. That's a best guess based on interviewing a smaller subset of people. Let's look at a few more. So we have the first example. A group of hotel owners in a large city decide to conduct a survey among citizens of the city to discover their opinions about casino gambling. What would our population be? What would our population be? Not necessarily people that have
the city over 21.
Yeah, I mean, the over 21, maybe not. Just depends on what their goal is. You don't 18 to vote. So policy regarding casinos, they might cut it off at 18. They're looking at people that can use casinos, maybe 21. So that might vary a little bit. But the important part is people of the city, citizens of the city. That's the population because they want to know what their opinion is. Okay. Would I include people from other cities? No. They don't care. They only care about the people of that city, what their opinion is on casino gambling. So that's our population. One of the hotel owners suggests obtaining a sample by surveying all people at the 6 largest nightclubs in the city on a Saturday night and ask them to express their opinion on casino gambling. Does that seem like it would be a good way to gather information about that population?
No.
Why not?
Because it's a small percentage of the population.
Well, I mean, when we're looking at samples, we're looking at small parts. So if someone goes to a nightclub, are they more likely to be in favor of casino gambling? Yeah, probably. Not for sure, but it's definitely it's a fair assumption, and it might not be, like I said, representative. Second example, city government wants to conduct a survey among the city's homeless to discover their opinions about required residence in city shelters from midnight to 6 a.m. So they want to ask the homeless population, hey, you're required to be in a shelter, or you might be required to be in a shelter from midnight to 6 a.m. How do you feel about that? So what is our population? Homeless people in the city. Okay? Because they're the ones being affected, so they want to know how they feel. So the city commissioner suggests obtaining a sample by surveying all the homeless people at the city's largest shelter on a Sunday night. Is that going to work out the way we want? Or is that going to be a good way to evaluate the population? The biggest shelter on a Sunday night.
But wouldn't that still not be everyone?
They're not all going to be in the shelter.
They should ask the people that can't have access to shelter.
They should definitely consider including them. Absolutely. So just picking the largest shelter on a Sunday night, those people probably want to be in the shelter, and it's nighttime. So they're like, yeah, I totally want to be here. This is great. It doesn't bother me at all. But people that aren't there, maybe they feel differently. So it's not representative of our population. And so that's where we come into random samples. So when we take a random sample, just because I pick random people doesn't mean it's a random sample. In order to qualify as a random sample, every person or object in the entire population should have an equal chance of being selected or surveyed or evaluated or chosen. Everybody in the population. When we're looking at whether or not a sample is random, it helps to think about, does a subset or a group of people or objects in the population have a higher or lower chance to be selected because of certain situations, like being in a home or not being in a home shelter, going to nightclubs or not going to nightclubs. So examples of random versus not random. If I gave you all numbers 1 through 30, so I ran out of numbers, and then I picked 5 numbers at random out of a bag, you all have an equal chance of being chosen. Because everyone has one number. A number shows up once. Cool. Not random. If you have a rock music radio station that asks listeners to call in and vote on what the best music genre is, any guesses on what they're most likely going to say?
Probably wrong.
Probably rock. Because they're listening to a rock radio station. If your favorite music is hip-hop, then you're probably not going to spend any of your time listening to a rock station. So, groups of people that favor rock music are more likely to call in. So we're not going to get a random sample. And then it comes down to making sure that we get something that is a representative sample. So if we go back to the hotel owners from the large city and the casino gambling, we want to figure out which of the following would be most appropriate. So we want to randomly survey people who live in an oceanfront condominium in the city. So it's random. Would that be a good representative sample? No. Oceanfront condominiums are expensive. Not everyone has an equal chance to be selected. You're also specifically picking one demographic region. So again, that's going to adjust your data. Maybe for the good, maybe for the worse, maybe no difference at all. But it's not a good sampling technique because not everyone has an equal opportunity to be selected. Survey the first 200 people whose names appear in the telephone record. It's okay. But does everyone have an equal chance of being chosen? No. Last name starts with an A or a B. So it's okay. It's better than the oceanfront condos, but still not great. Randomly select a neighborhood of the city and then randomly survey people within those selected neighborhoods. Yeah. Everyone has an equal chance. Pick 3 random neighborhoods, 6 random streets on each of those neighborhoods, and then 5 random houses on those streets. Survey all those people. Everyone has an equal opportunity to give their input about casino gambling. Maybe they're trying to add another casino and the people don't want one, but they do want one. I don't know. Bring money to the city, cause more crime. Could go either way. So you want to get a representative sample. Sample whose characteristics, that exhibit characteristics typical of those possessed by the target population. Okay? You want to try and get the most accurate picture of what the people as a whole have as an opinion. So there are a lot of different types of sampling techniques. We're not going to go into a bunch of detail on those different techniques, but we are going to talk in general about how we could make, improve on the suggested techniques. So again, the city commissioner suggested that we survey all the homeless in the city's largest shelter. We talked about why that isn't a good idea. So what would possibly be a better way to get that sample? Instead of going to the largest shelter on a Sunday night, what could we do differently? And it's a really good point about during the day, because then you're not targeting groups that may or may not be in a homeless shelter. So just during the day, homeless people tend to congregate in specific areas. So you can go to random areas, select a few, pick some people, see what they feel. And that would probably give you a representative sample for that situation. So that's where we're going to stop today. Next week we're going to talk about frequency distributions, and we're actually look at how to organize and collect the data, or actually how to organize it after we collect the data. So we'll start with our frequency distributions, and then deal with, well, what if we have a whole bunch of data and how to deal with that. And then throughout the unit, we'll look at how to interpret certain parts of the information to analyze and make assumptions. And we'll also look at some very deceptive ways that data can be presented, which even if you don't end up taking a statistics course, understanding how statistics works and then how it can be used to deceive you, since most of you will be of voting age very soon, very, very important. Because there's liars, and there's damn liars, and then there's statistics. Okay?